So I accidentally stopped my last video. I ended on the first side. What I was saying is this is kind of the basics of what we're going to do. On this second part of the video, you're going to get into some more difficult pieces. Maybe this is a way to do it for the better. I don't know. You can pick and choose or see if you can go ahead and do the back page and then turn this on and check the points as you go. But you're going to see some more difficult things that occur that I just want to make sure that you know can happen in this second part. And one of those things is we're going to see some rational exponents that are different than a half. So in particular, we're going to focus on thirds, and I want to show you sometimes they come out nice, as in 7, sometimes they don't. And then we're going to go down and work on 9 and 10, where you actually have to find the equation of the tangent line, but this time in slope-intercept form. In addition to a different form, they also only give us x, so we have to find y. So that's kind of what's in store for here. So here we go. For number 7, I am going to jump in and do my derivative dy dx. Chain rule, bring the power down, 2x minus 4 to the negative 2/3, because that's 1/3 minus 1, times the derivative of the inside. Now I want to evaluate this. Dy dx at x equals negative 2 means I plug in negative 2. So I get 1/3. 2 times negative 2 is negative 4 minus 4 to the negative 2/3. Again, that's right here. I plugged in negative 2 times 2. And this becomes 1/3 times negative 8 to the negative 2/3 times 2. This is what I want to focus on, what this means, this negative 2/3. The negative puts this in the denominator, and the fact that it's 2/3 makes me take the cube root of negative 8 and then square it. The denominator gives me the root, the numerator gives me what I do with it. So this gets rewritten as 1/3 times, this is 1 over the cube root of negative 8 squared times 2, that last 2 that's in the end. You could actually square the negative 8 and then take the cube root of it, or you can take the cube root of it and then square it. It depends on the problem. Actually, I change what I do depending on what I'm looking at. I do whichever's easier. And in this case, the cube root of negative 8 is pretty easy for me. I know that's negative 2, and then I'll square negative 2. So I end up with 1/3 times, again, the cube root of negative 8 is negative 2. Negative 2 squared is 4, so times 1/4 times 2. When I do my math, I get 2/12 or 1/6. There is my slope. So again, that's a little interesting thing that can happen. This one came out pretty nicely. I was able to do the cube root of negative 8 and square it, but there are going to be instances where I'm not going to be able to do that. And so we're going to see that in action in this next problem. So dy dx, again, if you want to pause and do your, in fact, why don't you do that? Pause and see if you can find your derivative, and then we'll come back with the derivative and read and then figure out the slope of the tangent at that point. When I did my derivative, I ended up with 2/3 times 2x plus 4 to the negative 1/3 times 2. And now I'm going to go ahead and evaluate it at x equals negative 1. So I'll plug that in 2/3. This is 2 times negative 1, so that's negative 2 plus 4 to the negative 1/3 times 2. That gives me 2/3 times 2 to the negative 1/3 times 2. I'm going to multiply these two things together right away, this and this. So I have 4/3 times 1 over the cube root of 2. So that's that 1/3 or negative 1/3 power. All right, now I want to get rid of that radical in the denominator. This is 4 over 3 times the cube root of 2. 4 over 3 times the cube root of 2. Sorry for that being scrunchy. I have to rationalize that denominator. This is something that's a little weird. Again, this is why I wanted to take the time and point this out to you, because when we have a square root in the bottom, I just have to multiply the top and the bottom by the radical to get rid of it. It doesn't work like that with a cube root, because I need 3 2's in order to get rid of the cube root, and I only have 1. So I have to multiply the top and the bottom by the cube root of 2 squared. So the cube root of 2 squared on the top and on the bottom, that's what I'm going to be multiplying by. So this will equal 4 times the cube root of 2 squared over 3 times the whole point of doing this is to get rid of that cube root. So now I have 3 2's under a cube root, so that's going to be 3 times 2. Again, the 3 was already there. The cube root of 2 cubed is 2. I can simplify by canceling the 2 off the top and on the bottom, so now I have 2 times the cube root of 4 all over 3. Sort of ugly, but doable. Again, a situation where it doesn't come out clean, it doesn't come out nice. I have to rationalize the denominator. Okay, so got those kind of tough guys done. Now let's take a look at what if I have to find the equation of a tangent line in slope-intercept form. And when I do it in slope-intercept form, that is the y equals mx plus b form. In order to do that, I'm still going to use point-slope form. I'm still going to use y minus y1 equals the slope times x minus x1, like we did in the previous video, and then I will rewrite it to get it in this form. I still need then, because I'm going to use point-slope form, I'm going to use y minus y1 equals the slope times x minus x1 to get it into this form. I'm going to use that to get slope-intercept form. So I still need the slope and a point. The slope will come from the first derivative. The point I'm going to have to evaluate. So keep in mind that this function has a y value, that's my output, and an x value, that's my input. My point will come from what is the output when 1 is my input. Well, let's start with the slope. We're going to find the slope first. So that's dy dx equals negative 1/2 times 3x plus 6 to the negative 1/2 power times 3, applying the chain rule. I'm going to evaluate that at the given x, at x equals 1. So I plug that in, negative 1/2, 3 times 1 plus 6 to the negative 1/2 times 3. However you need to do this, go ahead, figure it out, use your calculator, evaluate, pause, catch up with me. I'm just going through and evaluating each of these pieces. I usually just find it easier to kind of do it by hand, but again, whatever you need to do. So this is negative 1/2 times 1 over the square root of 9, which is 3, times 3 over 1. Those 3's are going to cancel out. I end up with a slope of negative 1/2. Oops, I wrote 1/3, but negative 1/2. That's that part right there. There is my slope. I found my slope that I'm going to use. It's going to be the same slope in both of these, but I'm going to start with this form to get it into this form. I'm going to start with point-slope form to get it into slope-intercept form. But in order to do that, again, I said earlier, I need a point. I've got my slope. This is my slope. Now I need a point. So I'm going to take this thing here and I'm going to evaluate that. I'm going to do that in a different color so it stands out a little bit better. So I'm going to evaluate this. So I'm finding the value of y when x is 1. The value of y when x is 1, so that's the opposite of 3 times 1 plus 6 raised to the 1/2 power. I'm encroaching on this next problem space. Oops, sorry. But that is the opposite of 9 to the 1/2. So that is the, remember the opposite isn't included in there, so don't be worried about it. I can take the square root of 9. I need to take the square root of 9, and whatever I get, I'm going to make it the opposite. So the square root of 9, that's what 1/2 power is 3. So this becomes -3. That means the point I'm going to be using is when I plugged in 1, I got out -3. So now I have my slope and I have my point, and now I can plug those into point-slope form. So I plug it into point-slope form. Y minus y1 equals the slope times x minus x1. And now that I have that plugged in, I have everything that I need in there, I'm just going to distribute, move things around, and get it into this form. So I'll distribute the 1/2, y plus 3 equals -1/2 x plus 1/2 minus 3 minus 3. I end up with y equals -1/2 x minus 5/2, or maybe you wrote it as -2.5. Either way, it doesn't matter, 2.5, whatever. But there is my slope-intercept form of that equation. All right, we've got one left. Same kind of thing. I like this problem too because it's a trig problem, and it uses pi, and we have to evaluate this problem when x is pi, and we also have to find the derivative when x is pi. And so I'm going to kind of divide that up a little bit. Again, sorry. So here I am. I'm going to do my derivative. dy dx involves a chain rule. The derivative of sine is cosine. Angle as is, derivative of the angle. Now I have to evaluate that at x equals pi, which means I just plug in pi. This is the cosine of 2 pi. And that whole thing is going to be multiplied by 2. So the cosine of 2 pi, remember where that is. Cosine of 2 pi is right here. That is the point 1, 0. So the cosine of 2 pi is 1. So this becomes 1 times 2, or 2. There is my slope. My m, my slope. I found the slope of this function at x equals pi, and now I need the point. So I'm going to go through and find the point for this function. So if y equals sine 2x, and x is pi, then this is the sine of 2 pi, which we found over here that the cosine of 2 pi, we had 2 pi over here, the cosine of 2 pi was 1, the sine of 2 pi is 0, so we're going to end up with 0 as our y value. So the point that we're going to use is pi comma 0. That's the point. So I have the slope, I have the point, I plug it into point-slope form. Point-slope form is y minus y1 equals the slope times x minus x1. Don't worry about that pi there. It's not a big deal. We're just going to distribute and clean it up. This turned out nice. We got 0 here. Great. This is y equals 2x minus 2 pi. That means I have a slope of 2 and a y-intercept of 2 pi. So that means when I graph this, this is going to go just around -6.28-ish, a little below -6 on the y-axis, and then my slope from there will go up to right 1, up to right 1. So those were sort of the more difficult things that you're going to see. Again, sorry about the video breaking up into 2. Maybe that works out good for some of you. Who knows? Well, we'll see. But hope it all goes well. And as always, if you have questions, ask.